means of an introduction, folks. My name is Callanan. I'm the Director of Applications Engineering at a company called Excelsys Technologies. We're an Irish company, privately held, and we've been designing power supplies for nigh on 15 years now. Our background has been designing specifically for the medical industry, for the military industry, for telecoms, and for some industrial also. And today I'm just going to share some of my experiences over the years in dealing with customers. And effectively the objective of today's presentation is to how to identify a potential power supply vendor for your needs. It's a fundamental building block of any application, but it is a surprise at times how little time is spent on sourcing the correct power supply for your needs. I'm going to advise you how to ensure you ask the right questions of your vendor, and also how to give yourself the confidence that you're choosing the right company as a vendor. So for today's discussion, I'm just going to talk about how to go about sourcing a power supply. I'm going to advise you what questions to ask and how to ask those questions. A key point is establishing that the power supply and the company, not just the power supply, but the company that you choose, are the right choice for your designs, because going forward effectively this will be driving your piece of hardware. I'm going to provide some examples where that's worked for us as a company, and more importantly I'm going to provide some examples of where it's gone completely wrong and how we've resolved those issues. And then we'll have some summary, and if there are any questions then we can take them at that stage. So how do you go about sourcing a power supply? The best advice I can give you is not to focus on finding a power supply, but finding an overall solution, something that would move with you as your development goes forward in time. What I'm showing you here is a graphic that we've put together to try to describe what we do as a company, and we provide the lowest total cost of ownership to you, not just for the purchase of the power supply, but for the whole duration of the project. We develop a customer and channel partnership, and that goes right through to our distribution channel. We provide leading edge products in order for you to achieve your solution, and we provide exceptional technical support. And if you get the right balance of the four of those things, you will have a long-term solution, not just for your project in the immediate future, but going forward for you as an engineer in designing your system. So what questions to ask and how to ask them? Well, effectively, anytime that you specify a power supply, you can categorize your requirements into three basic needs. You have your basic specifications, which will be the voltage and current. But the question that you need to ask is, what happens if my design requirements change? Not just in the short term, but in the long term. How can my solution that I've spent a lot of time qualifying and building up a relationship, how does that move forward with me? The form factor. Is it fixed, or do we have more options available? What happens if you, as a mechanical engineer, suddenly decide that the existing power supply won't fit into your needs? How can the power supply company that you're dealing with, how can they accommodate you in your new requirements? Every application, in particular in the medical industry, will have some critical factors. EMI, electromagnetic interference. This is where the power supply interacts with its outside environment and how it's influenced by the outside environment. We look at things like conducted radiation, conducted emissions, radiated emissions, electrical fast transients, electrical surge testing, and so forth. And how does the power supply and the test results that the company provides you with, how is that going to work when I integrate this power supply into my system? And what you need to have is you need to have a company that has a full understanding of EMI and how it interacts and interferes with your power supply. And they need to be able to support you as you integrate that into your supply, because you will not see the same results that they publish on their data sheets, because every system is going to be different, and a power supply is effectively just a component. So when you take a component and put it into your overall system, you will not get the same results that's published on the data sheets. Derating curves. How are they derived? How does a company tell you that a power supply can work up to 60 or 70 or 80 degrees Celsius, or down to minus 20 or minus 40? You need to dig a bit deeper and ask the company, how are they deriving these data sheets? What derating are they applying themselves in order to generate those? And also the other features, things like the transient characteristics. What happens when I turn it on? What happens when I turn it off? Approvals. And coming next year, the EN6601, what's commonly referred to as a third edition, it was derived in 2005, and every medical piece of equipment that is being shipped from June of 2012 next year will need to be third edition approved. So you need to ask your company that, is your power supply third edition approved? If it's not, are they going to get it compliant with third edition? So establishing and verifying the right choice. Effectively, it all boils down to reading the small print. Any vendor will give you the headlines, 92% efficiency, low profile, high density, and so forth, but you really have to read the small print. How is that going to perform over the lifetime of the product? How is that going to perform over the entire operating condition? How will it change with time? Will we see a temperature coefficient creeping in? Will we see the voltage drifting with time? And how does that affect your power system? The best advice I can give to you, and this may come across as being a bit selfish because this is where I earn my bread and butter, is to establish a technical contact who can engage with you right from the get-go of your design. What we've often found with not just in medical companies but all companies is that they spend a lot of their time developing their own system, and they spend very little proportional time developing in the power supply to drive that system. And when you think about it, the system can never function correctly if the power supply doesn't behave itself. So what we would advise as a company is try to engage from the get-go with a technical contact in that company who can advise you and move forward. It gives you the best opportunity for any flexibility or any change that would be required as you go through your design stage. One of the key things that you should do is consider the future expansion of your base design, because a lot of your design time is taken up by testing of new components that you're not familiar with. So if you want to qualify a new power supply vendor, you will need to satisfy yourself, not alone that this is the right part, but going forward, what happens if my design requirements change? Is it future-proof, or do I have to go back and requalify a new vendor if my requirements change? Demand engineering excellence and look for evidence of exceptional technical support. It's no different to that if you're getting a contractor to build an extension on your house. You'll ask the guy, show me where you've built before, show me some examples. Do the same with your power supply vendor. Ask them how they've solved problems. Get to know the guys who you'll be dealing with on a regular basis. And ensure that the technical team can support you, not just for your immediate needs, but for the entire duration of the project lifetime. If you're designing a medical system, it probably has a lifetime of 10 years plus. Within that 10-year period, things will and can and will go wrong. And you need to be sure that the company that you choose will be in a position not just to support you, but will want to support you. So ask for specific examples of where they've done that and how they support their customers long term. This is where we tell you where it went right. Okay? There's not a whole lot to learn from these, because if things are going right, it means that you've established the correct process. But I've just picked 3 good examples over the years where we've worked with customers from the get-go and where the system has come out favourably for everyone in the end. We deal a lot with about 25% of our business is designing for medical. And we were working with a customer in England. They had a very unique requirement in that they were looking to charge electrochemical cells. This was proprietary information that they had. It was their design, and they were unwilling or unable to share the details of the cells to us. And when they hooked up several power supplies to it, not ours, but they discovered that the power supplies were failing. They tried to engage with a number of vendors, and people weren't really willing to support them. Eventually, they got in contact with one of our distributors, and we offered some advice to them. We travelled over to their facility, and what we actually discovered was that their cells were behaving as a battery, and it was dumping energy back into the power supply. So what we actually worked with them, we designed an external card to fit in between our power supply and their end solution to resolve the issue. The result of it was we won the business, and now the guys are at the stage where they're an FDA approval and exporting to the US. A surgical laser diode application, 200 watts initially, working its way up to 1200 watts. As the guys were increasing the size of the power supply, one of the tests that it must meet is the flicker test. By flicker test, what we mean is that if the power supply is pulsing, we need to ensure that it doesn't interfere with the main supply. And the reason for that is that if it interferes with the main supply at a particular frequency, it can cause the lights to flicker. And if you happen to suffer from epilepsy, it can actually trigger epileptic fits. So for the 200 watt design and the 400 watt design and the 600 watt design, we never had any problem with the vendor. When they came to designing their 1200 watt laser, they realized that when they was failing the flicker test, What we actually did was that we designed again an external card that would fit in between our power supply and their system in order to pass the test. And the guys are moving forward now with their design. Another application where we were working with some designers in Israel was that it's a real-time diagnosis of breast cancer equipment. They noticed that with their particular setup that every few months or so they had a situation where they had to power cycle their system because it was getting into a latch-off mode. What we actually discovered was that with their particular setup, they were introducing some noise back into our power supply. And again, we worked with them to have an external fix to get that going. Again, there's not a whole lot that you can learn from this, because if things are going right, it means your process is correct and it's working. And where you really have an opportunity to learn and really an opportunity to improve your situation is where you learn from where things have gone wrong. Again, I've supplied 3 examples here of where it's gone wrong and how we fixed it and how we're preventing it from happening again. We had a customer who wanted to implement N+1 redundancy, and N+1 redundancy is where you have 2 power supplies in your system. If in the event of one power supply failing, the system should still continue to run with the second power supply. If you really and truly want N+1 redundancy, what you need to do is you need to have some form of isolation between the 2 power supplies. Otherwise, you could have a situation where if one power supply fails, it will actually pull down the second power supply. We explained this in great detail to the customer back in about 2007, but they were adamant they did not want to use blocking diodes. Really, we should have dug our heels in and we should have insisted on it, but it kind of fizzled out and they choose to go forward using our power supplies. Jump forward about 3 years later, suddenly they come back to us, they're telling us that the power supplies are failing, and hey, guess what, when one power supply fails, it's pulling down the entire system. Now, if you find yourself at the stage where you're arguing with your customer, it's a bit like arguing with your better half. You're going to lose that argument every time. There's no point in going back and reminding the customer of all the meetings that we had and where we had advised them, so we had to do a workaround. And the point I want to make here is that we never seem to have time to design it right the first time, but we always appear to have time to redesign it the second time when we're forced to do so. We're now working with that customer, again developing an external card for them to act as an O-ring FET effectively. Again, the second situation where it went wrong was that we worked for a long time it was a very specific piece of medical equipment. It was involved in major organ surgery. And it was a very complex solution that we arrived with the engineering team. By the time it went from the engineering team into production, the actual process that we had agreed to implement the solution, the production team felt it was taking too long to implement in their production. We weren't keeping up in regular contact, we weren't following up with the engineering team, and suddenly we heard that we were off the approved vendor list. The reason why we were taken off the approved vendor list is because the production team weren't happy with our power supply. The lesson to be learned from that was that we dropped the ball. We should have seen it right through to the end of the process. We didn't keep up a regular communication with the people, with the key decision makers, and that's something that we've learned moving forward. The final one is just an interesting story. We had a customer in France where we had offered a solution for them. Again, these guys were very, very intelligent, very high-end application. It was for a military application. We implemented we implemented a solution for them, and when we had our series of conversations, the guys were telling us that that's not working. We were adamant that it was working, that it should work and had to work. They were adamant that it wasn't working. So there was a bunch of us got a flight to London, got a connecting flight down to the south of France. Very nice, very sunshine day. Met with the engineers. They told us the extreme importance of this project and we had to resolve it, or we were going to be off the AVL. And by the time we got to the lab, we realized what the problem was. They hadn't connected up the wires correctly. So very ashen-faced engineers, all apologies. But again, the key to learn from here is that we knew that it was a complex solution, but we knew that the solution worked. We should have insisted in either getting over there and demonstrating the solution to them, or else getting their application into us and testing it and verifying it in the lab to have the results for them. Again, some lessons to be learned of where it's gone wrong and how we've moved forward. So, in summary, it's important that you research the company. It really is important. What you need to establish is the ability of the technical team to support you for the duration of your project. Engage with the technical teams as soon as you can. and share the information. Don't be afraid to hold back information, because if it's shared, and shared in a proper fashion, we can assure that we can come up with the most efficient solution for everyone. And a key point here is that create and foster long-term relationships, because going forward, that will help you to reduce the design time of your project. So I'm going to leave it there. If you have any questions, we're over in booth 2449. Please feel free to drop by and have any follow-up conversation on this. All right, thanks very much for your time, folks.